All right, let's do the solutions to November 2024 math paper 1. Right, looking at this question 1.1, solve for x, 1.1.1, x into x minus 3 is equal to 0. Whenever we have two things that are being multiplied together and we have a 0 on the other side, if there's no need for distribution, we can go straight into the answer. It's x is equal to 0 or x minus 3 is equal to 0. When we take minus 3 over, it gives you x is equal to positive 3. Don't forget your or. 1.1.2, 2x squared plus 1 is equal to 4x. Get that into standard form. Ax squared plus bx plus c is standard form. We first need that form, so we're going to go 2x squared minus 4x plus 1 is equal to 0. This, correct to 2 decimal places, is a dead giveaway that you need to use the quadratic formula. Right, so the quadratic formula is x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. Your a value is 2, your b value is negative 4, and your c value is 1. So we're going to sub that in. That's minus into minus 4 plus minus the root of minus 4 all squared minus 4 into a, which is 2 into c, which is 1. That's all over 2a. So it's 2 into 2. This whole thing goes in on the calculator. Don't do bits and pieces. You're first going to do it with the plus, and then you're going to do it with the minus to get your two solutions. And this is the only part in the paper where they mark you down for incorrect rounding off. So this answer is x is equal to 1,71 or x is equal to 0,29. I've seen this year when they're marking the papers, you can't go straight from this to this. They're not giving you the mark, or you're losing 1 mark if you don't show the substitution into the quadratic formula. So that's how they're marking it this year. So make sure that you show that substitution, right? Next one, we have x squared minus 2x minus 3 is greater than 0. That's an inequality. So the first thing you're going to do is you're going to factorize. You can have x and x, 3 and 1, minus there, plus there. Your critical values are 3 and minus 1. Now, there's two ways to do this. You can do the parabola at 3 and at minus 1. The parabola is going to smile because the a value is positive. So it's going to look like that. This is asking for greater than. Greater than 0 meaning positive. Where does the graph lie? Above the x-axis, there and there. So where x is less than, follow this arrow, less than minus 1, or where x is, follow this arrow, greater than 3. That's your solution there. Then we have 2 to the 2x minus 2 to the x plus 2 minus 32 is equal to 0. Whenever you have 2 to the x or a prime number raised to a variable exponent, if you can't see it immediately, then use the k method. So you're going to go let 2 to the x equal to k. So we have 2 to the 2x minus 2 to the x plus 2 minus 32 is equal to 0. I'm going to rewrite this as 2 to the x all squared. This and this is exactly the same thing, because when you multiply your exponents, you still get 2x. Minus, I'm going to split this up. This is 2 to the x times 2 to the 2 minus 32 is equal to 0. Now we're going to change the 2 to the x to be a k. So this is k squared minus k times 2 to the power 2 is 4 minus 32 is equal to 0. This is 4k. So it's k squared minus 4k minus 32 is equal to 0. We're going to factorize that. It's going to give us k and k and 8 and 4. That's a minus, that's a plus. So k is equal to 8 or k is equal to negative 4. But remember, k is 2 to the power x. That means when I take this, I can write 2 to the power x is equal to 8, or 2 to the power x for this one is equal to negative 4, which this one is no solution. because a positive base can never be equal to 0 and it can never be equal to a negative solution. Two things. A positive base raised to any exponent will never be equal to a negative number, and it will never be equal to 0. So you have to cancel out that solution. This one, you're going to prime factorize the 8. It gives you 2 to the power 3. Your bases fall away. X is equal to 3. Right, that was 1.1.4. Right, next. 1.1.5 is a surd question. You need to make sure that the surd is alone on one side of the equal to before you do anything else. This is a minus 2x plus 4 is equal to 2 plus x. Take this x over just so that the surd is alone on one side of the equals to sign. Once you have the surd alone, you're going to square both sides. Remember, what you do to one side, you have to do to the other side. And the reason we're squaring it is to cancel out the surd, the root. That then gives me a minus 2x plus 4 is equal to, this is, write the bracket twice and FOIL it out, or you can square out the binomial by going first times first times last times 2, last times last. All right. At this point, get everything on one side, 0 on the other side, and factorize the everything side. So this is 0 is equal to x squared minus 4x plus 2x. When you bring it over, it gives you a 6x on this side. 4 minus this 4 will give me 0. If I factorize this, the type of factorization is HCF. It's a common factor. You're going to take out x as a common factor. You're left with x plus 6. And then at this point, again, you have two things that are being multiplied, and the other side is a 0. You can go straight into your answer. X is equal to 0 or x is equal to negative 6. However, this sum, once you have your solution, you have to test it. And you test it in the step where the surd was alone. The surd was alone in the step. Minus 2x plus 4 is equal to 2 plus x. So in this step, where the surd is alone, you're going to test both solutions. And what you are testing for, sorry, is that underneath the root is not negative, because that's non-real, and that the answer to the root, on the other side of the root, that's also not negative. So we don't want under the root to be negative, and we don't want the answer to the root to be negative. So I'm going to take my first solution, which is x is equal to 0, and I'm going to sub 0 for x. This gives me a positive 2. And on the other side, I'm also going to sub 0 for x, and that gives me a positive 2. So 0 is fine, because both under the root and the answer to the root ended up being positive. Make sure that you noticed that I did not take the root when I was testing my solution. Okay, let's test the next solution, the minus 6. If I go minus 2 and I sub x to be minus 6 plus 4, this gives me negative 2 times negative 6 is a positive 12 plus 4, which gives me a positive 16. That's fine. But when I test the answer to the root, 2 plus minus 6, this gives me a negative 4. That means the answer to a root ended up being negative. And that's non-real. So what we need to do is we need to cancel out the solution of minus 6. Because remember, when you test either under the root or the answer to the root, both of them cannot give you a negative solution. And so you say no solution here. And that's your answer. All right. All right, 1.2. It says solve for x and y simultaneously. I'm going to do simultaneous by substitution. So I'm going to take my first equation, my linear equation, 2x plus y is equal to 3. I'm going to make y the subject of the formula just because it's the easier one to make the subject of the formula, because its coefficient is positive 1. So that's 3 minus 2x. This is equation 1. All right? In equation 2, which is y squared plus xy is equal to 2, wherever I see a y, I'm going to sub it with 3 minus 2x, because here I'm saying that y is equal to 3 minus 2x. Y and 3 minus 2x is the same thing. So in my next equation, wherever I see a y, I'm going to put a 3 minus 2x. So this y was squared. So the 3 minus 2x must also be squared, plus x into 3 minus 2x is equal to 2. This one, square out the binomial or write the binomial twice and FOIL it out. But I'm going to square it out first times last times 2, last times last. Distribute this in. We have plus 3x minus 2x squared is equal to 2. That then gives me a minus 2x squared. Add your like terms there. That's 4 plus 3 is 7. Minus 12 is minus 5x. And bring this 2 over. It's 9 minus 2, which gives me 7. So this is a plus 7 is equal to 0. I'm going to divide right through by negative 1 because I always like my x squared to be a positive. So it gives me 2x squared. Hold on. This is a square, sorry. Hold on. That was a square, 9 minus 12x plus that. That gives me that. Yeah, sorry. All right, okay. So I'm going to do that again. This is going to be 4x squared minus 2x squared gives me 2x squared. That's gone. Then minus 12x plus 3x is a minus 9x. And 9 minus 2, bring that 2 over, is a positive 7. That's the trinomial study. It didn't work out in the previous one. So this gives me, when we factorize 2x and x, it gives me 7 and 1. The last sign is positive, which means both brackets must get the same sign, and they must get the sign of whatever the middle term is. So in this case, we have 2 brackets equal to 0. We can go into the solution. We have x is equal to 7 over 2, or x is equal to 1. Once you have the values for x, you now need to take it and sub back into the original equation, any one of the two equations actually, either equation 1 or 2, but equation 1 is the simpler one to sub back into. So we have y is equal to 3 minus 2 into, the first answer was 7 over 2 for x. That gives us 3, that cancels, 3 minus 7 gives me minus 4. Or y is equal to 3 minus 2 into the second value for x is 1. And 3 minus 2 times 1 is just 1. So your x values are 7 over 2 and 1, and your y values are minus 4 and positive 1. All right, and then the last question is always a type of level 4 question. 1.3 says, consider the product 1 plus a half, 1 plus a third, 1 plus 1 over 4. Each factor of the product is of the form 1 plus 1 over n, for where n is greater than or equal to 2. Determine all the values of n for which the product will be an integer. Now, first understand what an integer is. An integer or integers are full numbers. No fractions, no decimals, but they form positive and negative numbers. So from negative infinity, right up until positive infinity, those are integers, but none of the fractions and none of the decimals involved, right? So fractions and decimals are not part of integers. All right, the first thing I'm going to do is I'm going to simplify this and convert all of these to improper fractions. Just add them by finding the LCD in each bracket, right? This is going to give me 2 plus 1 all over 2. This is going to give me 3 plus 1 all over 3. This is going to give me 4 plus 1 all over 4. And I'm going to do the same thing for this, by the way. It's n plus 1 all over n. All right? When we simplify that, it gives us 3 over 2, gives us 4 over 3, gives us 5 over 4. And if you continue this pattern, you're going to see it's going to give you 6 over 5, 7 over 6, so on and so forth, until you get to this, n plus 1 all over n. And what happens when you look at it nicely, you will see that because it's the product, you can cancel out that and that, that and that, that and that, that and that. It's going to cancel out every single thing. You'll know that even at the end here, if this was the last term, you would have n over n minus 1 here at the bottom. N over n minus 1 at the bottom. And these things would have cancelled out as well. This and that with the previous one, all of those cancel out. The only things that don't cancel out is this 2 and this n plus 1. So those are the two things that don't cancel out. They have nothing to cancel out with, which means, okay, sorry, that was my brother. Okay, so we said that everything ends up canceling out. And the only thing that remains that doesn't cancel out is this 2 and this n plus 1, which means that after you find the product of everything, the things that are left is n plus 1 over 2. This is a numerator, this is a denominator, all right? So now, in order for this to be an integer, we're going to test the numbers from 2 onwards, all right? So let's test the first number, which is 2. If I make n 2, it will be 2 plus 1 all over 2, which gives me 3 over 2. 3 over 2 is not an integer. We said integers are full numbers, no fractions, no decimals. Full positive and negative numbers, no fractions, no decimals. So that means that 2 doesn't work. Let's test the next number, 3. 3 plus 1 all over 2, that gives me a 4 over 2, which gives me 2. That is an integer. So the first number we tested was 2. Second number, this was not an integer. Second number we tested was 3. That was an integer. Let's test a few more, right? So let's test the number 4. So 4 plus 1, that gives me 5 over 2. That can't be simplified, so that is not a integer. So this is going to be 4, doesn't work. Let's test 5. Right, 5 plus 1 is 6 over 2. 6 over 2 gives you 3, which is an integer. So that means 5 works. I'm going to test 2 more. Right, let's go 6. That gives me 7 over 2. 7 over 2 is not an integer. That doesn't work. So 6 doesn't work. 7. 7 plus 1 is 8. 8 over 2 is 4. That is an integer, so that works. So what we're noticing here is that all the odd numbers greater than 2 produce integers for this, n plus 1 all over 2. And so you can answer that n is equal to 3, 5, 7, so on and so forth, all the odd numbers. And you can say and make a final conclusion that n will be all the odd numbers greater than 2. Greater than 2. Okay, I hope that made. All right. Question 2, 2.1 says the first term of an arithmetic series is 7, which means A is equal to 7. The common difference of the series is 5, which means D is 5, and the series contains 20 terms. So 2.1.1 says, calculate the sum of this series. So we're going to, simple enough, open up the sum formula for this arithmetic series. It's Sn is equal to n over 2 into 2a plus d into n minus 1, or n minus 1 times d. Either way, doesn't matter, right? Okay, so there's 20 terms in the series. That means wherever I see an n, I'm going to put 20, because that's the number of terms in the series. 20 over 2 into 2. A is the first term, which they told me was numerically 7. So this is 2 into 7, plus D is the common difference. They told me it's 5 into N, which again was 20 minus 1, and close both those brackets. Put the whole thing in on the calculator exactly as you see it and get your answer. The answer here ends up being 1090, which means that the sum of the first 20 terms of the series is 1090. Then we have 2.1.2 says the original arithmetic series is extended to 75 terms. So from 20 terms, it's extended to 75 terms. The sum of these 75 terms is 14,400. using sigma notation, write down an equation for the sum of the terms added to the original series. So meaning not the full 75, they just want in sigma notation the sum added to the first 20, which means that there's 55, the remaining number of terms is 55 terms. They want us to write those 55 terms down in sigma notation. So we're going to open up our sigma sign. And the first thing we do when we write something in sigma notation is find the general term of that series. So the general term of an arithmetic series is a plus d into n minus 1. A is the first term, which is 7. D is 5 into n minus 1. That gives me 7 plus 5n minus 5, which gives me 5n plus 2. This generally goes on the side of my sigma sign, which is 5n plus 2, right? And then the top of the sigma sign is the number of terms in the series. The top of the sigma sign is the number of terms in the series, which in this case is 75. Now, we need to figure out what we're finding the sum of, right? So obviously, sigma sign stands for the sum of. They're not talking of the full 14,400. Remember, whenever you take a sigma sign and you make it equal to something, the thing on the other side of that sigma, on the other side of the equals to sign, I should say, is the sum. So they're not talking about the full 14,400. They're talking about the 14,400 minus the original first 20 terms. And the first 20 terms, remember the sum of it was 1090. So they're talking about this, which is the full 75 minus the first 20. So 14,400 minus 1090 gives me 13310. So they want the sum, or the written in sigma notation, the sum to 13,310. Now, normally at the bottom of the sigma sign is n is equal to 1. That's what we normally put at the bottom of the sigma sign. However, we are not saying that the full 75 terms of the sigma of the series adds up to 13,310, because that's not true. We're saying that the amount of terms that adds up to 13,310 is the 75 minus the original 20. So at the bottom, I can't start with 1, because if I'm starting at 1, I'm saying that there's 75 top minus bottom plus 1. I'm saying that the sum to 75 terms is 13,310. That's not true. The sum to the first 75 terms is 14,400. So how do I adjust n at the bottom to give me just the sum of the remaining 55 terms? So meaning the 75 minus the first 20 terms. How do I adjust n at the bottom? What do I put for n? So that I'm talking about the remaining 55 terms, i.e. the 75 terms minus the original first 20 terms. This is what we do. Remember, normally in sigma notation, if a sigma sign was given to you, you say to calculate the number of terms in the series, you say top of the sigma sign minus bottom plus 1. Right? That's what you say. Now we know that this is the remaining 55 terms, the sum of the remaining 55 terms. So I know that the amount of terms in this series that adds up to 13,310 is 55. So I'm going to say top, which is 75, minus bottom, I don't know what that is. That's what I'm trying to figure out, plus 1. And then I'm going to solve for what this bottom number should be. So I'm going to take that bottom over. So bottom here is going to become a positive there. That's 75 plus 1 minus 55. Right? It gives me the bottom to be 21. So this has to be n is equal to 21, because now when you look at it, when I say top minus bottom plus 1, top the number of terms in the series that adds up to this is top minus bottom plus 1. That gives me the 55 terms that does add up to the 13,310. I hope that made sense because it was a long explanation, a little bit of a tricky one, right? Okay, let's look at the next. All right, it says the sequence of the first differences of a quadratic pattern is 1, 3, 5, so on and so forth. If T99 of this quadratic pattern is 9,632, calculate the value of T98. Now, there's a bit of theory that you need to know here, all right? If they're talking about T99 and T98 of the quadratic number pattern, you first need to understand the relationship between a quadratic number pattern and its first difference. You see, between T1 and T2 of the quadratic pattern lies T1 of the first differences. And the first differences, remember, of a quadratic number pattern is arithmetic. Between T2 and T3 of the quadratic lies T2 of the arithmetic. Between T6 and T7 of the quadratic lies T6 of the arithmetic. Between T17 and T18 of the quadratic lies T17 of the arithmetic. So between T98, and T99 of the quadratic lies T98 of the arithmetic. Right? I hope this theory makes sense. So now when we're looking at that bit of theory, let's just delete that quickly. All right. So we said between T98 and T99 of the quadratic lies the first difference. The first difference is term, to be T98. So here's the thing. The first thing I'm going to do is I'm going to figure out what the general term of the arithmetic pattern is. Right? The general term of this pattern is Tn is equal to dn plus q, or you can go the long one, Tn is equal to a plus t into n minus 1. I'm going to go dn plus q. D is the common difference, which is 2. Q is what you do to d to get the first term. What should I do to 2 to get to 1? I need to subtract 1. So you can go this method, or you can go the long method where you don't have to think about it, right? This is the general term of the arithmetic sequence. So you know you have your quadratic sequence, whatever it may be, right? Between T1 and T2 lies the T1 of arithmetic. Between T2 and T3 lies T2 of the arithmetic. Between T3 and T4 of quadratic lies T3 of arithmetic. Now, if I have the general term of this and I want the numerical value there, then all I need is the general term of this arithmetic series, which I now have the general term of the first differences of the arithmetic series, right? And I need the value of T98. So if I get the value of T98, this is how I'm going to do it. I'm going to sub in place of n here, 98, 2 into 98 minus 1. That's going to give me, no idea, give me 1 second. Let me put it in on the calculator. It's going to give me 195. So T98 is 195. So this is 195. I know that T99 of the quadratic pattern, meaning this top pattern, is 9632. So how would I get the value of T98? It's this minus that. So to get T98, I'm just going to say 9632 minus 195. It gives me T98 of the quadratic to be 9437. And that's it. Okay, right. The next one All right, the next question says, if it is further given that the third term of the quadratic pattern is 32. So T3 of the quadratic pattern is 32. Determine the general term Tn of the quadratic pattern. So very simply, first of all, we have a quadratic pattern, whatever it may be. All right, I know that the first differences, sorry, is given to me. It's this, right? So this is 1. This is 3, this is 5. All right. Now, they're telling me that T3 is 32, which means this is T1, T2, T3. They're telling me that this is 32. So to get to T2, all I'm going to do is 32 minus 3, which gives me 29. And then to get to T1, all I'm going to do is say 29 minus 1 will give me 28. And then remember, with a quadratic number pattern, we take it down to its second difference, which is generally or always common. All right. So now if they want the general term, this is the formula. You go 2a is equal to the second difference. 3a plus b is equal to the first difference. And a plus b plus c is equal to the first term of the quadratic pattern. So we start from the bottom and work our way up. That's 2a is equal to 2. Divide both sides by 2. A is equal to 1. Then we have 3 into 1 plus b is equal to 1. B is equal to, take that over, it becomes -3. So 1 minus 3 is -2. And then A plus B plus C must be equal to 28. That gives me a -1 there. If I take it over, it's going to be a positive. So C is equal to positive 29. And so therefore, the general term of the sequence is Tn is equal to an squared plus bn plus c. And then a is 1n squared plus bn is minus 2n plus 29. And that's the general term of the quadratic sequence. All right, I hope that made sense. All right, question 3 says, a circle with radius 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. 3.1, write down the radius of the third circle. So this one. Sorry, they want the radius of this circle, right? So the radius of the first circle is 6. It's given to me. The radius of the second circle is going to be half of that. So this is the radius of the first circle, right? So the radius of the second circle, which is this circle, is half of the first circle's radius. This is the first circle's radius. It's 6. The radius of the second circle is half of that, which is 3. And then this is also 3. So the radius of this smaller circle is half of this 3, which is 3/2. Half of 3, which is 3/2. Right? That's as simple as that. Okay. Calculate the sum of the areas of the first 10 circles. Now they're asking me in terms of area, which means I need a sequence for areas, meaning I need the first 3 terms for the areas of the 3 circles. So area T1 of the first the biggest circle, the outermost circle, that area is pi r squared. So it's pi into 6 all squared, which gives me 36 pi. T2 is pi r squared also, but r in this case is 3. So this gives me 9 pi. And T3, again, pi r squared, but r is 3/2 all squared. That gives me 9/4 pi. So these are my first 3 terms. This, that, and that is the first 3 terms of the areas of the circles. So they are asking me to calculate the sum of the areas of the first 10 circles. So I'm going to calculate S10. But before we do that, let's write down the formula for a geometric pattern, because this is geometric. You multiplying to something the entire time. You're multiplying to 1 over 4 the entire time. How did I get 1 over 4? To get R, your common ratio, what you're multiplying to the entire time, it's T2 over T1. 9 pi over 30 over 36 pi. 9 pi over 36 pi. The pi's cancel out. 9 over 36 is 1 over 4. So I have my common ratio, but Sn for a geometric sequence is a into 1 minus r to the n all over 1 minus r. Right? So they want the sum to the first 10 terms, this is S10, is equal to a, which is 36 pi, into 1 minus r, which we just figured out is a quarter. Keep a bracket, a quarter to the 10 all over 1 minus a quarter. And the answer here gives us 150,80. That's the areas of the first 10 circles added, the sum to the areas of the first 10 circles. The next question says, which diameter has which circle has a diameter of 3 over 128 centimeters? So again, they're not asking me based off of the radius. They're asking me based off of a diameter. Just like in this 3.2, they asked me a question based off of area. So I got the first 3 terms of the first 3 circles areas. I need to do the same thing here in 3.3. They are asking me based off of diameter. So I'm going to form a sequence of the first 3 circles diameters. So the first circle's diameter would be this radius plus that radius, which is 12. Right? So the first diameter for T1 is 12. The second diameter is this one, which in this case is 6. That's T2. And the third diameter is this one, which is 3. Right. Again, you are multiplying to a half the entire time. How did I get that? R is equal to T2 over T1. Again, it's 6 over 12, which gives me a half. So I'm multiplying to a half the entire time, which makes the series a geometric series. They're asking me which circle has a diameter of 3 over 128, which is simply asking me which term is 3 over 128. So I'm first going to get the general term of this geometric series, because this mentions nothing about sum. So that's why we're not using Sn, right? So I'm going to get the general term. A is 12. R is a half, all to the n minus 1. Tn, they are asking me, it needs to be 3 over 128. So which circle has the diameter 3 over 128? So Tn needs to be that 3 over 128. And then you need to solve for n to get which circle it is. The first thing I'm going to do is I'm going to divide both sides by 12. I have no idea what that is. Give me 1 second. Right, it gives me 1 over 512 is equal to 1 over 2 all to the n minus 1. You're solving for an exponent. So I'm going to make my bases the same. This is 1 over prime factorize that 512. 512 equals shift fact. Gives me 2 to the 9 is equal to 1 over 2 all to the n minus 1, which I can write this as 1 over 2 all to the 9. Because remember, 1 to the 9 is still 1, right? That's equal to 1 over 2 all to the n minus 1. Your bases are now the same. They fall away. 9 is equal to n minus 1. Take that minus 1 over. N is equal to 10. That means that the 10th circle has a diameter, which is 3 over 128. All right. Okay. Right. Question 4. It says, given f of x is equal to a to the x minus 1 for where a is positive, b is 2 and minus 5 over 9. It's a point on f. 4.1, calculate the value of a. Simple enough. You're going to take your set of coordinates that you have. You're going to sub it in for x and y and solve for a. So we have f of x is equal to a to the x minus 1. I'm going to take my set of coordinates minus 5 over 9 in place of y and 2 in place of x to solve for a. I'm going to take that 1 over. It's going to become 1 minus 5 over 9 is equal to a squared. That gives me 4 over 9 is equal to a squared. Square root, don't forget your plus minus. But a is a positive value. They told me that there. So a is going to be positive 2 over 3. All right. Then it says write down the range of f. Now, f is an exponential graph. We can clearly see that because x is the exponent, which makes this an exponential graph. But there's just two things that needs to be in your mind. You need to have the graph in your mind, obviously, but on the graph, there's two things that you need to see in your mind's eye. All you need is the asymptote, first of all, which is on minus 1. Right? The asymptote is on minus 1. And then this set of coordinates that lies on the graph, you need to see if it's going to lie on top of the asymptote or below the asymptote. So 2 and minus 5 over 9, 2 and minus 5 over 9 is here. However this graph goes, whichever direction it goes, it matters not. All I need to know basically is that the graph lies above the asymptote because this set of coordinates lies above the asymptote. And so if the graph lies above the asymptote, that makes the range y is above, greater than, on top of the asymptote, which is minus 1. No equal to. Why not? Because minus 1 is an asymptote. Okay. Then it says, sketch the graph of f, clearly show the intercepts of the axis and the asymptotes, if any. So very simply, when you're sketching this graph, the first thing you do is you draw your asymptote. Your asymptote is here, the loose number at the back. It's minus 1. All right, that's minus 1. Then you need your y-intercept. So there's always 3 things you need in order to sketch an exponential graph. So my exponential graph is this, by the way. It's 2 over 3 all to the x minus 1. So the first thing is your asymptote. Second thing is your y-intercept. You find your y-intercept by making x equal to 0. So you have y is equal to 2 over 3 all to the 0 minus 1. Anything to the power of 0 is 1 minus 1. That gives you 0. So your y-intercept is here at 0 and 0. And then you have a set of coordinates that lies on the graph. It's 2 and minus 5 over 9, which is here. And so the graph is going to be drawn through both points. That is f of x. Right. Then it says, it is further given that C is a point on f at the y value 19 over 8. Determine the coordinates of the image of C when C is reflected about the line y is equal to x. So first of all, let's get the full set of coordinates for C, because currently all I have is C's y coordinate. C's y coordinate is 19 over 8. Now, if C lies on F, C is a point on F, then I can find this by subbing this whole set in place of x and y in my equation, because it lies on my graph. So my equation is y is equal to 2 over 3 to the power x minus 1, right? That's the equation of f. I'm going to take this set of coordinates, I'm going to sub it in place of x and y and solve for the unknown. So y is 19 over 8 is equal to 2 over 3x is x minus 1. So I'm solving for x here. I'm going to take that minus 1 over. It's going to give me 19 plus 1 gives me a 27 over 8 is equal to 2 over 3 all to the power x. I'm going to prime factorize the 27 and the 8 individually. It's going to give me 3 to the power 3 over 2 to the power 3 is equal to 2 over 3 all to the x. Right. At this point, I'm going to swap these around. I'm going to go 2 to the minus 3 over 3 to the minus 3, just because I want the 2's on top, just like it is here, and I want the 3's at the bottom, just like it is on the right-hand side. So when you swap up and down to the numerator and denominator, remember you are playing with the sign of the exponent, not the sign of the base, not the sign of the base. You're playing with the sign of the exponent. So once I have that, I can write this as 2 over 3 all to the minus 3 is equal to 2 over 3 all to the x. And that gives me x to be minus 3, which means C's coordinates is minus 3 and 19 over 8. This is the original C. But that's not the question. The question said, determine the coordinates of the image of C when C is reflected about the line y is equal to x. And when you reflect about the line y is equal to x, x's become y's and y's become x's. So the image of C, x's are becoming y's and y's are becoming x's. And that's the answer for that one. All right. All right, question 5 says, sketched below is the graph of f of x, that's hyperbola, having the domain minus infinity to 1 and 1 to infinity. That means excluding 1, right? Which naturally then means that 1 is the asymptote of this hyperbola. 1 is the vertical asymptote of this hyperbola. And so automatically that makes me want to put in this 1 here. And so before we even read further, because 1 is the asymptote, positive 1 is the asymptote, this has to be minus 1. Okay, the graph of f cuts the y-axis at 0 and 1. A line of symmetry of f is given by, this is the axis of symmetry of the hyperbola, right? It's the one with a positive gradient, so y is equal to x minus 3. Okay, write down the value of p. We already have the value of p. We said it's minus 1. P is equal to minus 1. We put it in here, right? The next question then says, determine the equation of the horizontal asymptote of f. Now, to get the horizontal asymptote, we're going to use this axis of symmetry. Normally, when we are trying to get the axis of symmetry, we use the bean method. So we have y is equal to a over x minus 1 plus q. And to get the axis of symmetry, we use the bean. Right? So we use the bean and we say y is equal to x minus 1 plus q. This is what we do to get the axis of symmetry with a positive gradient. This is the one with a positive gradient, right? Now they're telling us that g of x is the axis of symmetry of f. So the one with a positive gradient, g of x is y is equal to x minus 3. Now that means that if this is how I would normally get it, that this part has to be equal to minus 3 because they gave that to me, right? So normally when everything is given to me, I use the bean method, right? And I say y is equal to x minus 1 plus q, but they already gave me the axis of symmetry, which means I know that this back part has to be equal. And so for me to get that q value, I'm going to say minus 3 must be equal to minus 1 plus q. Take that minus 1 over. That gives me minus 3 plus 1, which is minus 2. So q is negative 2. So they say determine the equation of the horizontal asymptote. So yes, q is, q is minus 2. But the equation of the asymptote is y is equal to minus 2. Remember, when they ask you for an equation, you have to give it in terms of x and y. So this answer is y is equal to minus 2. Then the next question says calculate the value of a. So what we have right now is we have y is equal to a over x minus 1 minus 2. That's what we have. If I want the value of a, I just need to find a set of coordinates that lies on my hyperbola, i.e. that, to sub in place of x and y and solve for the only unknown, which in this case will be a. My set of coordinates is 0 and 1. So this is 1 is equal to a over 0 minus 1 minus 2. Take that minus 2 over, it gives me 3 is equal to a over minus 1, which is a minus a. Cross multiply or do whatever you need to do. That gives you a is equal to negative 3. And so here the value of a is negative 3, which means my equation of my hyperbola is minus 3 over x minus 1 minus 2. For which values of x is f of x greater than and equal to 0? Rephrase this question. F of x being greater than and equal to 0 simply means where does the graph of f, the hyperbola, lie above, greater than, lie above the x-axis? Where is the hyperbola above the x-axis? Just rephrase the question for it to make sense to you, right? It's above the x-axis from here to there, right? So between whatever this x value is, from this x value to this x value is where the hyperbola is above the x-axis. Now I need to figure out what this x value is, and this x value is simply the x-intercept of the hyperbola. How do I find the x-intercept of the hyperbola? We make y equal to 0. Hold on. Right, so I'm going to make y equal to 0. 0 is equal to, that's a minus 3 over x minus 1 minus 2. Take that minus 2 over. It gives me 2 over 1 is equal to minus 3 over x minus 1. I just put it over 1 to cross multiply. That's minus 3 times 1 gives you minus 3 is equal to 2 into x minus 1. That gives me minus 3 is equal to 2x minus 2. Take the minus 2 over. That's minus 3 plus 2, which is minus 1 is equal to 2x. Divide both sides by 2. So x, the x-intercept of the hyperbola is minus a half. So this x-intercept is negative a half. So the hyperbola lies above from minus a half to 1. How do we write that? We write minus a half, x in the middle, 1, and the inequalities must face the margin, both of them. You don't have one this way and then one that way. That's not right. Sorry. Both of them must face the margin as long as the smaller number is on the left. Okay. And then this question had an equal to. So that begs the question, does both of the inequalities get an equal to? No. This one will get an equal to, this one will not, because 1 was the asymptote of the hyperbola. And so your answer is that the graph, the hyperbola, will lie above the x-axis from minus a half to 1. You will include the minus a half because the question has an equal to. You will put an equal to in the solution, but the 1 will not get an equal to because 1 is an asymptote. Okay. The graph f undergoes a transformation to h, where the domain and range of h and f, domain and range of h are the same as that of f. Domain and range is the same. Give me a second. Let's see what's going on. Domain and range would be the same if it reflects there or it reflects there. Okay, so the domain and range are the same for h and f. H prime, the derivative, is negative on its domain, okay? And then describe a possible transformation that f could have undergone to result in h. I think the main thing here, this is here to confuse the heck out of you, but the main thing is this. If you focus on this alone, I think you'd get the answer. The domain and range of h and f are the same. That's going to happen if you fold over this line. So meaning if you reflect across that line. If I reflect across that line, this graph is going to lie here. And this graph is going to lie here. And then the domain and range would still be exactly the same. You see the domain is x is an element of real, but x is not equal to the asymptote, the vertical asymptote 1. And the range is y is an element of real numbers, but y is not equal to minus 2. This minus 2, yeah. So the domain and range for both of these pink graphs, let's change the color of this. Let's say We're looking at that graph, and we're looking at this graph, right? So if you're looking at the domain and range of the pink graph and of the blue graph, it gives you the same domain and range. And that's if I folded over this line, which means if I reflected across that line. So one of the transformations, because it says give a possible transformation, right? One of the transformations is a reflection across the vertical asymptote. Reflection along vertical asymptote, or you say a reflection along x is equal to 1. That's the vertical asymptote. However, there is also another solution here that I can see. It's if you reflect over the horizontal asymptote. So here we reflected over the vertical asymptote. But what happens if I reflect over the horizontal asymptote? Right, this is my original graph. This one is going to lie here. And this one is going to lie here. And the domain and range, again, will be exactly the same. And that's if I fold over this line, which means another possible solution, this is done, by the way, you can also say a reflection across or along the horizontal asymptote, which is the line y is equal to -2. This is the line y is equal to -2. A reflection along y is equal to -2. So any of these solutions would have worked. All right? Okay. Right, question 6. It says, in the diagram below, the graphs of f of x is equal to minus x squared plus 4x plus 5 and g, a straight line, are drawn. C, the point 3 and 8 is a point of intersection of f and g. EH is drawn parallel to the y-axis, which means it's a vertical distance, with E on point F and H a point on G. Okay. So parabola, straight line. Calculate the coordinates of B, the turning point of F. So to calculate the turning point here, I'm just going to go x is equal to minus b over 2a. That gives me minus 4 all over 2 into minus 1, which gives me minus 4 over minus 2, which is 2. Take that sub back into the into the original equation. So this is f of 2 is equal to minus 2 squared plus 4 into 2 plus 5. That then gives you an answer of 9. So B's coordinates is 2 and 9. Right. Next question. It says, show that the equation of the line through A and C is given by g of x is equal to 2x plus 2. So they're basically asking us to find the equation of the straight line, G. I need 2 sets of coordinates on that graph to find the gradient. I'm going to find this set of coordinates first, A. A is the x-intercept of both the straight line and the parabola, but I don't have the straight line's equation, so I'm going to take the parabola's equation and make y equal to 0 to get the x-intercepts of the parabola. So that's 0 is equal to minus x squared plus 4x plus 5, divide right through by minus 1 so that the x squared can be positive. So this is 0 is equal to x squared minus 4x minus 5. That gives me x and x, 5 and 1, minus there plus there. X is equal to 5 or x is equal to minus 1. Obviously, then A's coordinate is minus 1 and 0 because A is on the negative side of the x-axis. So once I have A's coordinates, which is negative 1 and 0, I'm going to find the gradient of AC. So the gradient of AC is y2 minus y1 over x2 minus x1, which is a minus minus 1. Right? That gives me 8 over 3 plus 1, which is 4, which gives me the gradient as 2. Then we're going to go y is equal to mx plus c. This was not worth 3 marks. But anyways, this is the gradient. So you're going y is equal to 2x plus c. I'm going to find a set of coordinates that lies on that graph. We're going 8 is equal to 2 into 3 plus c to solve for c. That's 8 is equal to 6 plus c. Take the 6 over. That's 8 minus 6. So c is equal to 2. Therefore, the equation of g of x is the gradient 2x plus 2, which is what they asked us to prove. All right. Next question says, calculate the maximum length. Maximum length, the word maximum, immediately, what should pop into your brain? Find the derivative and make it equal to 0. Whenever you have synonyms of the word maximum or minimum, find the derivative, make it equal to 0. So yeah, they said calculate the maximum length of EH. EH is a vertical distance. They said if F is greater than G, meaning F lies on top of G. So this is top minus bottom. Right? EH is a vertical distance. You're going to go top minus bottom. The top graph is the parabola. So E lies on the parabola and H lies on the straight line. So the top graph is the parabola, which is minus x squared plus 4x plus 5. Minus the bottom graph is the straight line, right? Which is 2x plus 2. This is EH, right? EH is equal to minus x squared plus 4x plus 5 minus 2x minus 2. Add your like terms, simplify. That's minus x squared plus 2x, and that gives you 5 minus 2, which gives you a plus 3. At this point, you're going to find the derivative. This point where you can't simplify any further. You're going to find the derivative. It's going to give you minus 2x plus 2, and you're going to make it equal to 0. Take that over, that gives you 2x is equal to 2, divide both sides by 2, then x is equal to 1. This is not the answer. This is what will produce the answer. You're going to take this and sub back into the original equation, the equation before you found the derivative. So just the step before you found the derivative, you're going to sub back in there, and you're going to say EH max is equal to minus 1 squared plus 2 into 1 plus 3. And that's going to give you the answer of 4. And that's the maximum length, okay? All right, so 6.4 says, given k of x is equal to f of x plus m is equal to that whole long drama, determine the value of m such that g is a tangent to k. Now this tangent theory, there's two of them. You see, when they come complicated like this whole long drama that they're giving you, the method that I'm going to do is the safer one. However, just go over the two tangent theories that you have in paper 1. One of them is when they're asking you about tangent, you find the derivative f prime x. And then that f prime x is the gradient at the point of contact between the tangent and the curve, right? And so either you sub in the gradient if you have it at that point of contact, and you get the x value of the point of contact, and hence the set of coordinates at the point of contact, or they would have given you the x coordinate at the point of contact and asked you for the gradient or the equation of the tangent, right? That's one bit of tangent theory. But the other bit of tangent theory is when they're asking you if one line is a tangent to the other, or one graph is a tangent to another. Like they're asking you in this question, and then you have to apply nature of the roots. Nature of the roots would then be an easier way to solve it, although you could also do it with a derivative. But in this case, it's better for you to use the nature of the roots theory. And there is a video explaining the nature of the roots to the grade 11s, right? So go and check that nature of the roots video on nature of the root shifts and the tangent theory in there. So this question says, given k of x is equal to this whole long equation, determine the value of m such that g, which is this graph, is a tangent to k. So this theory, this tangent theory that I'm talking about of nature of the roots, this is how you apply it. The first thing you're going to do is when they ask you if one graph is a tangent to another, you're going to equate those two graphs. So you're going to say 2x plus 2 must be equal to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. So equate g of x to k of x, right? This is k of x, that's g of x. The next thing you need to do is get this equation that you just formed in the form ax squared plus bx plus c is equal to 0, which means there must only be one x squared in your equation, and there must only be one x in your equation, right? One question like this did come out in your June, I'm pretty sure. I'll go and check it again though. But this is what you need to do. We're going to get this entire equation in the form ax squared plus bx plus c is equal to 0. So I'm going to have a 0 on one side already. I'm going to check for x squareds. The only x squared that I see is this one, which means I already only have one x squared in my sum. Then I already dealt with that. Then I'm going to deal with the x's. So the x's is this one. That one has an x. That one has an x. And that one has an x. So I'm going to write it here. I'm going to write it here at the bottom just to manipulate it so I can already put it into the sum, right? It's 2x on this side equal to, and then you have minus 2mx there and plus 4x. Right, I'm going to get the 0 on the side. It's minus 2mx plus 4x minus 2x. Plus 4x minus 2x gives me a 2x. Right? And I only want one x in my equation. So here I already have 2. How do I get 1? I just pull out x as a common factor. So this is going to give me x into minus 2m plus 2. Right? But I'm going to put the x at the back. It's the same thing. So here I'm going to have a plus minus 2m plus 2x. And then everything else in the sum that doesn't have an x attached will be c, sorry. My brain's not working. Everything else in the sum that doesn't have an x attached to it will be part of the c value. So when we have ax squared plus bx plus c, everything that does not contain an x or an x squared will be part of the c value. And so this is going to be minus m squared plus 4m plus 5 minus 2 is a plus 3. Right. And so that means I now have my equation in the form 0 is equal to ax squared plus bx plus c. Right? Once you have your equation in that form, ax squared plus bx plus c, you are now going to say for tangent, for g to be a tangent to k. Right? For it to be a tangent, delta must be equal to 0. So this question can come 3 different ways. It can say such that g is a tangent to k. It can come such that g is a secant to k, such that g is an exterior line to k. 3 different ways. And then the way that it starts is always the same. But this is where that question differs. So if the question said such that g is a tangent to k, you will make the statement. For tangent, delta must be equal to 0. Had the question changed and said secant, then you would say where delta is greater than and equal to 0, or not even equal to, just greater than 0, right? That's a secant. And had the question said an exterior line to k, where it does not intersect k at all, then you would say delta must be less than 0. So that's the only part where the calculation would change. But this question asks us for tangent. And so we're going to say b squared minus 4ac must be equal to 0, because delta is b squared minus 4ac. I'm going to pull my a, b, and c values. My a value is everything except the x squared. So it's ax squared. So a is minus 1. My b value is everything except the x, which in this case is minus 2m plus 2. And my c value is everything else in the sum, which is minus m squared plus 4m plus 3. Right. Now, at this point, we're going to sub in our a, b, and c. b is minus 2m plus 2 whole squared, minus 4 into a, which is minus 1, into c, which is minus m squared plus 4m plus 3. That's equal to 0. And there's only one unknown now. it's M, and that is what they asked you to solve for. It said, yeah, determine the value of M such that G is a tangent to K. And so now you're going to do normal basic algebra, and we're going to solve for M. It's going to give me, I'm just going to distribute this out. That gives me first times first is 4M squared. First times last times 2 gives me minus 8M. And last times last gives me a 4. This times this gives me a positive 4. Right? I'm going to distribute that positive 4 in. So that's positive times a negative M squared is a negative 4M squared. Positive times positive is positive 16M. And positive times positive gives me a positive 12 is equal to 0. Add your like terms. 4M squared minus 4M squared cancel, right? That gives you minus 8M plus 16M gives me a positive 8M. And 4 plus 12 gives me a 16. That's equal to 0. Take the 16 over, so 8M is equal to minus 16. Divide both sides by 8. M is equal to negative 2. All right. I hope that made sense. And we're on to the next. All right, question 7. It said Mary's grandparents deposited 5,000 Rand into a savings account on the day that she was born. The account pays interest at a rate of 6.8% per annum compounded quarterly. Calculate the accumulated amount in this account on Mary's 16th birthday. How do you know which formula to use? A, F, P. You're going to use A. The reason you're going to use the A formula is because there was one singular payment made. There's no continual payment made. So that means I'm going to use the A formula. A is equal to P into 1 plus I to the power N. Why to the power N? Because this is compound interest, compounded quarterly. So they deposited 5,000. Here P amount is 5,000. 1 plus the interest rate is 6.8%. That 6.8% is compounded quarterly. So we're going to divide by 4 and immediately raise to the power 4. 4 times. So they deposited it on the day she was born, and calculate the accumulated amount in the account on the day she turned 16. So 4 times 16. 16 years, right? Don't overthink N if you don't have to overthink N. It's just 16 years at 4 payments per year, which gives you 64. And then the whole thing goes in on the calculator exactly as you see it. This is 14,706 and 56 cents. Okay, after 4 years, the value of a printer was half of its original value. Determine the rate at which the value of the printer depreciated over this period if depreciation was calculated according to a straight line method. All right. So the first thing we're going to do is we're going to open up the formula for depreciation on a straight line basis. This is 1 minus I times N. So the value of a printer was half of its original. So at present, whatever it is, it's X. In the future, it's half of X, right? This is 1 minus I don't know what I is, and it was over a period of 4 years. So can I call this 4I instead of I4, right? 4I. And then we're going to calculate this here. We're going to divide both sides by X. And the only reason we can divide by X here is because we know X is not 0. Remember in math, you cannot divide by an unknown unless, of course, you know that that unknown is not 0. That will then give you a half is equal to 1 minus 4I. Take the 1 over, it's a half minus 1, gives you a minus a half. Sorry, hold on. This gives you a minus a half is equal to minus 4I. Divide both sides by minus 4. Minus 4. That gives me I is equal to 1 over 8. And because it's an interest rate, you're going to multiply that to 100 to get it to be a percentage. And that means R, the interest, is equal to 12.5%. All right, that was that one. Super simple. Let's look at 7.3. 7.3 says, Tebo was granted a loan of 100,000 on the 1st of March 2022 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. Tsepo agreed to repay the loan over 5 years in monthly installments of 2,398 cents, starting on the 1st of April. So he started a month after the loan was granted, which means that there was that 1 month's grace, obviously, right? And so there's no delayed payment. That's when he's supposed to start paying. Calculate the total interest that he will pay over the 5 years. So to get the total amount of interest paid, you need to calculate how much he paid in total and subtract the original loan amount. Right? So let's see how much he paid. He paid 2,398 cents every month for 5 years. So 12 months per year for 5 years. All right. So that means this amount times 12 months times 5 years. That's the total amount that he paid over the 5-year period, which gives you 138,058,80. This is the total amount that he paid. To get the total amount of interest that he paid, you simply subtract the 100,000 loan. And that will give you the total amount of interest he paid. So it's 38,058 Rand and 80 cents. This is the amount of interest that he paid. All right. Tsepo paid 2,300. They made a mistake here. 2,398 cents, his monthly installment, and an additional 20,000 on the 1st of March 2024. So remember, the loan was taken out. The loan was taken out on the 1st of March 2022. Right, so they say that he paid his monthly payment, which is 2,398 cents, and an additional 20,000 on the 1st of March 2024, which means at that time, before this payment on the 1st of March 2024, he had already made 24 payments, because for 2022, so 2022 and 2023, he already made 12 payments per year for 2022 and 2023, which means in total he made 24 payments before this. So he had already made 24 payments, 23rd payment. So now it says, sorry, he continues to pay the original monthly installment thereafter. How many months earlier will Tsepo repay the loan? So the first thing I'm going to do is I'm going to calculate the outstanding balance on the loan after the 2 years, 2022 and 2023. I want to know how much is left on the loan. I want to still loan. So I'm going to calculate outstanding balance is A minus F. So it's 100,000 into 1 plus I, which was 13.5%. That's compound. Remember, N here in this formula is the number of payments that had already been made. I want to calculate the amount of payments, the outstanding balance on the loan after the 24th payment. So after the first 2 years. Right, this is minus F, which is X into, sorry, let me just write out this formula, X into 1 plus I to the power N minus 1 all over I. So this is X, which is your 2,398 cents, your monthly installment. 1 plus I is still 13.5%, all over 12, all to the 24. The N values must be the same for both. And then that's minus 1 all over I, which is 13.5%. Don't forget your percentage sign over 12. This whole thing goes in on the calculator. It's going to give me the outstanding balance on the loan to 64 Rand and 94 cents. Now, this amount is the amount outstanding after the first 2 years of him paying 2,398 cents for the first 2 years. right? Now, before he makes this payment on the 1st of March 2024, I calculated the outstanding balance and I said, okay, let's see if he were to make the 20,000 Rand or to pay the 20,000 Rand now, this outstanding outstanding balance on the loan would no longer be 67,804 and 94 cents. It would be this amount minus the 20,000. Right? Because now on that day, when he's making his payment, he's not just making his monthly installment payment, he's also making an added installment of 20,000. So instead of looking at the outstanding balance of the loan to be this, I'm going to minus the 20,000 also to get the total outstanding balance on the loan to be 47,804,94. That's the outstanding balance on the loan now. And so in order to see how many months earlier he will repay the loan, I'm now going to put that into the P formula to get the number of months earlier that he pays the loan. So I need somewhere else to write on. All right, so now this is the outstanding balance after the 2 years. Let's put the 20,000 down. Now that's the outstanding balance, right? So now we have P is equal to X into 1 minus 1 plus I to the negative N all over I. The P amount now is 47,804,94. Your X is still the same amount of the monthly installment that he's making, which is 2,398 cents. Into 1 minus 1 plus 13,5% over 12, all to the minus n. That's what I'm solving for. This is all over I, which is 13,5% all over 12. How do you solve for n here? Remember, this calculation, when you're solving for n in P and in the F formula, the use of logs is very important, and the way that you do the math here is very important. So I said, very simply, first of all, you're going to take this amount, you're going to press the divide button on your calculator, the actual divide button, not the fraction button, and you're going to divide by the bean. Right? All right, so let me punch this in. This is going to take me a while. Give me 1 second. We have 47,804,94 divided by the bean, 2,300,98 over 13.5% over 12. All right, this gives me on this side a 0,233 so on is equal to 1 minus 1 plus 13,5% over 12 all to the minus n. I'm going to take that 1 over. So my 1 will give me a negative 0,766 dot 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 is equal to a negative 1 plus 13,5. Divide both sides by minus 1, then these negatives will disappear. All right, now this is all to the minus n, by the way. Now you can add the word log to both sides. Add the word log to both sides of the equation and bring that exponent to the front. So you're left with log 0,766 whatever else is equal to minus n log 1 plus 13,5% over 12. At this point, all you need to do is solve for n. So divide by everything that's next to n. So divide by the negative, divide by the log of that whole bracket. So minus log 1 plus 13,5% over 12. But what you do to one side, you must do to the other. So this is minus log 1 plus 13,5% over 12. This whole thing will go in on the calculator. This cancels with that. That's gone. And you're just left with n on this side. And so n ends up being 23,80. 23,80. Which is approximately 12 months earlier. Because remember, let's say this is 24, right? Right. Remember that this payment or this whole arrangement is supposed to end at the end of 5 years, which is 5 years is 60 months. Right? It's supposed to be 60 months. So this 24 plus the first 24, that's 24 plus 24 gives you 48. Right? And so it's supposed to end in 60 months, but it's going to end in 48 months, which means it's going to end 12 months earlier. So I'm going to say that one more time. This is approximately 24 months, right? There's 24 months that we just calculated, plus the first 24 months that they paid before the 20,000 installment. So the first 2 years, the 24 months of that, plus this 24 months gives you 48 months. Right? And the entire loan was supposed to be paid off over a period of 5 years, which there's 60 months in 5 years. So how much earlier will the loan be repaid? 60 minus that 48, which gives you an answer of 12 months earlier. All right, I hope that made sense. All right, calculus, question 8. It says 8.1, determine 8.1.1, the derivative of 3x minus 5x squared. That's a straightforward derivative. Remember the notation here, when you have d over dx in a bracket, d over dx in a bracket of 3x minus 5x squared. To find the derivative, in the step you find the derivative, you drop all the drama and replace it with an equal to. Drop all of this drama, replace it with an equal to show them that you're finding the derivative. When we find the derivative, it's 1 times 3, just gives me a 3, and 1 minus 1 gives you a 0, so that whole x falls away because x to the power 0 is 1. And then 2 times minus 5, 2 times minus 5 gives me a minus 10, and subtract 1 from the exponent, which just gives me x to the power 1. I'm not going to write it in, right? Next one. It says find g prime x if g of x is equal to all of that. Okay, simple. We have g of x is equal to 2 over x squared minus the cube root of x to the power 7. So first of all, I need to bring this x up, and I need to take this x out of the third. So this is 2 to the 2x to the minus 2. And this, when you're taking it out, it's inside over outside. So 7 over 3. This is still g of x. I'm now ready to find the derivative. So I'm going to change my notation to g prime x. Exponent times coefficient gives me a minus 4. And subtract 1 from the exponent, minus 3. Then again, exponent times coefficient, that gives me a minus 7 over 3. Bring down the x, subtract 1 from the exponent, that gives me 4 over 3. And that's done. All right. Determine the equation of the to f of x. Here's again the tangent theory. At x is equal to 2. This is the first tangent theory. It's not the one with nature of the roots. So it's the first tangent theory because they're not asking if one graph is a tangent to another. So all we're going to do is we're going to apply our first tangent theory, which says find the derivative of f of x first. Right? So we have f of x, it's this. Then find the derivative, f prime x. That's going to give me 3x squared minus 8x plus 2. This derivative stands for the gradient. It's a gradient formula for a tangent anywhere on this curve. This is a gradient formula for any tangent at any place on this curve. But we want the gradient of the tangent at x is equal to 2. So remember, we're trying to find the equation of the tangent, an equation of a straight line. A tangent is a straight line, am I right? So I want the gradient at x is equal to 2. So it's a simple matter of me subbing in 2 in place of x. Because it's telling me x is equal to 2. All right, that will give me the gradient at x is equal to 2, -2, when we punch that whole thing in. All right, so this is the gradient at x is equal to 2. Now, when I'm trying to find the equation y is equal to mx plus c, I know that the gradient is -2. But I now need a set of coordinates to sub in place of x and y in order to solve for c to get my equation of my tangent. All I have is the gradient of the tangent to be -2. So if I want a set of coordinates, all I have to do is take this x value, sub back into the original equation, always the original equation, to get the corresponding y, just so that I have a set of coordinates that lies on the graph. So I have f of 2 is equal to 2 cubed minus 4 into 2 squared plus 2 into 2 plus 3. I'm going to put that whole thing in on the calculator to get the corresponding y value, and the corresponding y value is -1. So my set of coordinates is 2 and -1. That's my set of coordinates. I'm going to sub that in place of x and y here. So this is -1 is equal to -2 into 2 plus c. That gives me -1 is equal to -4 plus c. Take that -4 over. It's going to give me 4 minus 1, which is 3. C is equal to 3. Therefore, the equation of the tangent is y is equal to -2x plus 3. Right. I'm glad that this paper had both those tangent theories. Go back and learn them and go over them. So this tangent theory is, again, I'm going to say, it says determine the equation of the tangent to f at x is equal to 2. The first thing you're going to do is find the gradient. Find the derivative, sorry. The derivative then gives you the gradient, a formula for gradient anywhere on the curve. We wanted the gradient at x is equal to 2, so we subbed in the x value to be 2. We got the gradient of the tangent to the curve at x is equal to 2. Once we had that gradient, we needed a set of coordinates to sub in place of x and y to get our equation of our tangent. And so how did we get the set of coordinates? We already were given the x value of the set of coordinates. To get the corresponding y, you just simply take that, sub it back into the original equation to get the corresponding y, and then take that set of coordinates, which was 2 and -1, with the gradient that we calculated of -2, and solve for c. All right. Right. Given f of x is equal to -6x squared, determine f prime x from first principles. Right, first principles is a formula, you need to learn it. Right, so we're first going to find f of x plus h. That's the first thing you need to do. F of x is equal to -6x squared. Then that means wherever I see an x in the original, I'm going to replace it with an x plus h. Get rid of the brackets. This is first times first times times 2, last times last. Distribute that 6 in, minus 6x squared, minus 12xh, minus 6h squared. Then you open up your formula, that's f prime x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Right. Bring down the limit as h tends to 0. Replace f of x plus h with its equation. It gives me minus 6x squared minus 12xh minus 6h squared, and minus f of x's equation, which is minus 6x squared, which makes it a positive 6x squared, right? This is all over h. Right. This and this ends up cancelling out. Positive and negative are the same thing. You're now left with the limit as h tends to 0 of minus 12xh minus 6h squared. I'm going to pull out h as a common factor there on top. Sorry, this is minus 12x minus 6h. This is all over h. The reason I'm doing that is to cancel out the h in the denominator so that when I sub h to be 0, I'm not left with an undefined solution. So this is the limit as h tends to 0 of minus 12x minus 6h. In the step where I'm going to sub h to be 0, I'm going to drop the limit. So in this step where you sub h to be 0, you drop the limit. And then you get your answer. That just gives me minus 12x. That's the derivative, f prime x. Okay, that was that. Right, the next question says, write down how you will restrict the domain of f such that the inverse of f is a function. Now this question is from inverse functions, and the trick is that it's always the same. It's always x is greater than or equal to something, or x is less than and equal to something. The something is the x coordinate of the turning point of the parabola. Because this question of restricting the domain mainly comes out with the parabola. So it's always this. This is always the answer. You just need to figure out what that is. And 99.9% of the time in matric, that answer is 0. Because this graph, the parabola, looks like this. It turns at the origin. And I said when you restrict the domain, it has to be x is greater than and equal to the x coordinate of the turning point. And the x coordinate of the turning point here is 0. And so that's also 0. And so your answer is x is greater than and equal to 0, or x is less than and equal to 0. But remember, if it's not this kind of this kind of parabola where it doesn't turn on the origin, then this value must be whatever the x coordinate of the turning point is. Okay? But it always starts like this. Got it? Right, next. Determine the equation of the inverse for where the inverse is less than 0. So where the graph lies below the x-axis. Right, okay. So very simply, we're first going to pull out the equation. The equation is y is equal to minus 6x squared. If I want the equation of the inverse of this graph, I have to swap x's to y's to x's, and then I need to make y the subject of the formula. So I'm going to divide both sides by minus 6 here, which gives me a minus 1 over 6x is equal to y squared. And then I'm going to square root, and I'm going to square root. Right. Don't forget your plus minus. So now I have y is equal to either plus or minus 1 over 6x. Now, because they said this, where y is negative, I'm going to pull out the negative version of this. Meaning where x is less than and equal to 0, less than 0. If you don't know this theory, so you're going to have the negative in front of the bracket, and you have to have the statement where x is less than and equal to 0. If you don't know this theory of the parabola's inverse, you need to go to the grade 11 Google Classroom and watch the video on this. Okay? Oh my. Okay. All right. That's that. That's the equation, right? On to question 9. All right. Question 9. A and B are the turning points of the graph f below. C is the y-intercept of f. For which values of x is f decreasing? So you always look at the graph from left to right, and you ask yourself, where is the graph going down? Because if you look at it this way, the graph is going to go down here and here, and that's incorrect, right? You're always looking at the graph from left to right. And from left to right, the graph is going down from there to there, right? In this direction. Right. So the graph is going down from 1 to 5 over 2. So for which values of x is f decreasing? It's decreasing from 1 to 5 over 2. For which values of x, put an x in the middle. always face the margin as long as the smaller number is on the left. No equal to for increasing and decreasing questions. Don't ever put an equal to for increasing and decreasing questions. There's a bit of an argument about that right now, but for right now, don't put an equal to whenever the question has anything to do with increasing or decreasing. Write down the x-intercepts of f prime, the derivative of f. The x-intercepts of the derivative graph would be the same as the x coordinates of the turning point of the original. I'm going to say that one more time. The x-intercepts of f prime is the same as the x coordinates of the turning points of f. So the x-intercepts is 1 and 0 and 5/2 and 0. Those are the x-intercepts of the derivative graph. For which values of x will f be concave up? So it's concave up here. That's the smile. This is concave down. But now we need to find the point of concavity, the point of inflection, or the point of concavity, meaning where the graph changes from concave down to concave up, the point where it changes. And to find the point of concavity, we have to find f double prime x. F double prime x. It's also the midpoint between the two turning points. So if I don't have the graph's equation, I can just find the midpoint between the two turning points if they give that to me, and then I can find the point of concavity. And the midpoint here, let's call it m, x of m, it's equal to x of a plus x of b all over 2. That gives me an answer of 7/4. So your point of concavity here is, the x value of the point of concavity is 7/4. It's concave up after that. It's a smile, concave up after the 7/4. So this arrow, you're going to follow that arrow. You're going to say x is greater than 7/4. Had they asked you for concave down, it's concave down before that 7/4. So you follow this arrow, you go x is less than 7/4 if they asked you for concave down. But they asked us for concave up, and so my answer here is where x is greater than 7/4. All right, so this 9.4 says determine the value of k for which y is equal to f of x plus k will have 3 positive x-intercepts. Now, normally this question is asked like this. They say f of x is equal to k. F of x like that is equal to k. Something like that. Or f of x plus k is equal to 0. But when it's asked like this, where they have y is equal to f of x plus k, this plus k means that the graph is undergoing a vertical translation, where you're adding or subtracting something to the graph, the back of the equation, to y. You're adding or subtracting something to y. And so that means that the graph is moving either up or down. Now you need to figure out how it's moving or how it should move so that the graph will have 3 positive x-intercepts. That's what you need to figure out. And so this is what we're going to do. Remember, the graph is only moving vertically. It's not moving horizontally, right? So if I take this graph, right, and I shift it down, because currently I need the graph to have 3 positive x-intercepts. Currently it only has 1 x-intercept, and the x-intercept is a negative x-intercept, right? So what I'm going to do is I'm going to make it undergo a transformation or translation, a movement, a vertical movement. I'm going to shift the graph down. So I'm going to shift the graph down so that it will get to a point where it has a turning point on the x-axis. So at this point where it has a turning point on the x-axis, right, it has 2 x-intercepts. So it has this x-intercept that's negative and this x-intercept that's positive. But again, that's not what I want. I want the graph to have 3 positive x-intercepts. Let me just see if I shifted that correctly. Sorry, it would be there. Right. It wouldn't have one negative, one positive. It would have 2 positive x-intercepts. If I shifted it so that the first turning point was on the x-axis, right? But that's not what I want. I want the graph to have 3 positive x-intercepts. And so if I shift it a little further down, just a little, and you look at this. At this point, the graph has 3 positive x-intercepts, right? So first it was here, where the turning point lied on the x-axis, right? When the first turning point lied on the x-axis, that was a movement 8 units down. So from this turning point to this turning point, this was a move 8 units down. So a translation -8, right? It moved 8 units down, just so that this turning point could lie on the x-axis. But when the turning point lied on the x-axis, it only gave me 2 positive x-intercepts. And I don't want 2, I want 3. So I said, let's move it a little further down. If we moved it a little further down, it then gave us 3 positive x-intercepts, which is what I want. But now I can't move it too far down, because what's going to happen is, if I move it too far down, it's going to end up with just 1 positive x-intercept. And I want 3 positive x-intercepts. So this is what I want you to do. I want you to shift the graph twice. I want you to shift it so that the first turning point lies on the x-axis. And then I want you to shift it again so that the second turning point lies on the x-axis. Hold on. Right. So this was the first turning point coming down. This is the second turning point coming down. Right? This was a translation 8 units down. And this was a translation 9 units down. All right? And so here's the thing. Any graph that's a duplicate of these that is drawn between these 2 graphs will have 3 distinct positive x-intercepts. What did I just say? Any graph that is drawn between these 2 graphs, the blue and the green, will have 3 distinct positive x-intercepts. Let's test that out. If I were to draw a graph between the blue and the green, right, it will have 3 positive x-intercepts. So that must mean that K, the movement, the translation, or the movement of the graph down, K has to be a translation between 9 units and 8 units down, which means between -9 and -8. K has to be a translation between 9 and 8 units down. So how do I answer that? I can say that K is a movement anywhere between -9 and -8. Any value between -9 and -8, if you move the graph, you take the original graph and you move it anywhere, or a number, you translate it, a number down, but a number that lies between 8 and 9. A translation of 8 and 9 units down. Well, that's why I have the negative, to show that it was a translation downwards. Then the graph will be between the green and the blue, and it will have 3 distinct positive x-intercepts. I hope that made sense, because, geez, there's a lot to explain. Okay, question 10. A cyclist rode from town P and stopped at town T. So it started at town P, stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by the equation S prime T is equal to minus 3T squared plus 18T. Okay, just stop for a second, right? If this is a parabola and this is the derivative, that means the original S of T is a cubic function. A t cubed, normally it's an x, a t cubed plus b t squared plus ct plus d, but there's no part of that because this part is at the back is blank. So I'm just going to say from reading that information, this is the speed, right? S prime t is speed. And remember, when it's given in this form, this becomes the distance. And they said it here, speed is the rate of change in distance with respect to time. So if they're finding a derivative, then that must mean that the original, if the derivative is a parabola, then the original had to have been a cubic function. All right, and that's how it's supposed to look. So it said, calculate the maximum speed that the cyclist reached on this ride. So they're asking you for maximum speed. Speed's equation is y is equal to y minus 3t squared plus 18t. This is the equation for speed. Let's not call it y, let's call it s prime t. But I don't want you to get confused with this prime, right? This is just a formula. Just call it this. Right, this is the formula for speed. Now, if they're saying maximum, it means find the derivative of whatever formula speed has. So find the derivative of the formula for speed, because they're asking you for maximum speed. And whenever you see the word maximum, you have to find the derivative and make it equal to 0. But find the derivative of what? The speed's equation, which means I have to find the derivative of this equation. And so if I do that, it's going to represent S double prime t. That gives me minus 6t plus 18. When you're saying maximum speed, you have to make it equal to 0. And you're going to solve for t. So this is 6t is equal to 18, divide both sides by 6, then t is equal to 3. All right. No, that's the time that he reached maximum speed. You're going to take it, you're going to put it back into your speed equation. So S prime 3 is equal to minus 3 into 3 squared plus 18 into 3. And you're going to get an answer for the maximum speed that the cyclist reached. And the maximum speed is 27. All right. Okay. That's that. The next question, 10.2, says, calculate the distance between town P and town T. To calculate the distance between them, the first thing I'm going to do is I'm going to calculate when the speed was 0. The first thing I'm going to do is I'm going to calculate the time at which the speed was 0, because this says the cyclist rode from town P. So at town P, his speed was 0. And he stopped at town T, and that's also where his speed was 0. So I'm going to calculate the time taken for him to travel from town P to town T. That's the first thing I'm going to do. And the way that I'm going to calculate it is by calculating at what time equation, which is S prime T. And I'm going to calculate the time at which his speed was 0. Right. This I'm going to divide right through by minus 3. So that gives me 0 is equal to t squared minus 6t. Factorize that. That gives me t is equal to 0 and t is equal to 6. So at town P, at time is equal to 0. He was at town P, and at time is equal to 6. He time is equal to B, and at time is equal to 6, he was at town T. Right. Then what I need to do is I need to figure out what the distance formula is. I need to figure out what this is. And the way to do that is, if this was the distance formula, S of t is equal to AT cubed plus BT squared, right? This is the distance formula. I'm going to find the derivative as it stands. It's going to give me 3 times A gives me T squared, and 2 times B gives me plus 2BT. That I also have the derivative equation here. And so the reason that I'm doing this is to solve for A and B, and you'll see how now, right? This is also S prime T is also equal to minus 3T squared, 18T. So if this is the derivative and this is the derivative, then that must mean that this part of the derivative before the T squared and this part before the T squared must be equal. And this part before the T and this part before the T must be equal, right? Because they both S prime T, both of them, right? The one I got from the original equation, the cubic functions equation, and the other one I got from the information. So now when I make them equal, I'm saying 3A is equal to minus 3. I'm going to divide both sides by 3. That's going to give me A to be minus 1. And yeah, I'm going to say 2B must be equal to 18. Divide both sides by 2. That means B is equal to 9. And for my distance, this is distance, remember. S of T is equal to A, which is minus 1, T cubed, and B, which is 9T squared. Right. That is the equation for the distance. That is the equation for the distance. Now, I need the distance at time is equal to 6 because he started at time is equal to 0, ended at time is equal to 6, and this is where he stopped at town T, which means that that is the distance between P and T. When he reaches 6, whatever it is, meters or kilometers, whatever it may be, kilometers in this case, when he reaches time is equal to 6 hours, when he reaches a time is equal to 6 hours, that is the total distance between town P and town T. So I'm going to say at time is equal to 6 is where he stopped. And so that will give me the distance between town P and town T. When you sub all of that in, it gives me 108. And so that's the distance between town P and town T. I hope that made sense because that was also tricky. All right, question 11, they brought a little bit of grade 11 into this paper. It said, a certain number of learners are sitting for examinations in mathematics, tourism, and geography. All these learners sit for at least one of these examinations. So already from all the points that they're giving, I know that this is going to be a Venn diagram. But from the first point that they're giving me, whatever the Venn may look like, I know there's nothing outside the Venn because they say all of these learners will sit for at least one of these examinations, which means the number outside here is 0. Total number of learners who sit for mathematics. Okay, they give us all of that information. 11.1, draw a Venn diagram to represent all the... Okay, let's do that quickly. Okay, that's not my intention. All right. Let's go. This is mathematics, tourism, geography. Right. The total number of learners. Okay, before we get to these three, because these three talk about each subject individually, and I don't just want the individual subject's information yet, right? So I'm going to start here. It says 5 learners sit for mathematics and tourism, but not geography. 5 learners sit for mathematics and tourism. So the overlap between mathematics and tourism is here, but they're talking about just mathematics and tourism, not geography. So this is 5 learners here. 4 learners sit for mathematics and geography. Overlap between mathematics and geography is there, but not tourism, meaning not including tourism. That's 4 of them. That's it, just for mathematics and geography. Had I put it in this whole area, or, well, we'll get to an example like that, right? Okay, 3 learners sit for tourism and geography, but not mathematics. 3 learners sit for tourism and geography, but not mathematics. So we're looking at 3 learners there. 6 learners sit for only geography. So only geography, there's 6 learners there, right? This part specifies the learners that take only geography. Now I'm going to start from the second point because we already read that one. We did that one, we did that one, we did that one, we did that one. It says the total number of learners who sit for mathematics is 22. So this whole circle of mathematics needs to add up to 22, but I'm still missing this part, right? I'm going to go into geography, the point on geography, this circle, right? This whole circle, the total number of learners sitting for geography is 18. So that whole circle needs to add up to 18, which gives me this missing part. Because I can say 18 minus 6 minus 4 minus 3 will give me this part, because that entire circle needs to add up to 18. So 18 minus 4 minus 6, that's 8 minus 3 gives me 5. 5. Am I right there? Oh, sorry, I'm making a mistake here, sorry. 6 learners sit for only tourism. 6 should be here. That's my bad. Okay, sorry. Right, so this whole circle needs to add up to the tourism one. Sorry, I read this as geography in my brain. Okay, so this entire yellow circle needs to add up to 16. And so 16 minus 6 is 10, minus 5 is 5, minus 3 is 2. So this circle, this missing part of the circle is 2. Right, I hope you understood that. I'm gonna say it one more time, just because I messed that up. It says 6 learners sit for only tourism. The 6 learners that sit for only tourism is this part. This is the tourism circle, so 6 needs to be there. This was unknown, so we said that this whole tourism circle needs to add up to the total number of learners sitting for tourism, which was 16. And so to get this missing part, we said 16 minus 6 minus 5 minus 3, which gives us the 2. And so once we have that middle part, we can do the rest of them. The total number of learners who sit for mathematics is 22, which means this entire circle needs to add up to 22. So to get this missing part, it's 22 minus 5 minus 2 minus 4, which gives me 11. 11 learners sat for only math. And then the last one is geography. It said that the total number of learners sitting for geography is 18. So this entire circle needs to add up to 18. So 18 minus 4 minus 2 minus 3 will give me the number of learners that sit for only geography, which in this case is 9. 18 minus 4 minus 3 minus 2. Right. And so that is your Venn diagram completed. The next question says, calculate the probability that a learner chosen at random will sit for examinations in at least 2 of the subjects. Again, I said when the word at least or at most comes out, you need to think of it in terms of suites. If I say, give me at least 2 suites, I'm asking you for 2 or more. At least 2. I'm asking you for 2 or more. But if I say, give me at most 2, that means I don't want any more than 2. So that means 2 or less. This question is saying, calculate the probability that a learner chosen at random will sit for examinations in at least 2 subjects. At least 2 means 2 or more. 2 or more is these subjects. These are 2. That's 2 or more. The one in the middle is 3. So to get the probability, you're going to say 5 plus 4 plus 2 plus 3 all over your total amount of students that's set for examinations, which is all of these combined. And the total amount of students is 40. And then you get your answer. Your answer here is 0.35. That's the probability that a learner chosen at random will sit for at least 2. Probability of at least 2 subjects. Right, okay. Determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. Now, for this independent question, you have to prove that the probability of the first event and the second event is equal to the probability of the first event of the second event. You have to prove the product rule. So we are trying to prove that the probability of mathematics and tourism is equal to the probability of mathematics times the probability of tourism. That's what we're trying to prove. So this is how we prove it. If this statement is equal, meaning this side of the equation ends up equaling to that side of the equation, then the events will be independent. But if it's not equal, then the events are not independent. So first, let's figure out what the probability of M and T is. So if you look at M and T, sorry, this is 5. Right. Probability of M and T is this overlap. Right? This is M and T. And that is 7/40. Probability of M and T, the overlap between mathematics and tourism, is 7/40. Then the probability of mathematics alone. Probability of mathematics alone is 22/40. So it's 22/40 times the probability of tourism alone was 16. This was 22/40. This is 16/40. Right. Now you're going to punch it in on the calculator and you're going to see what the decimal is. So this ends up being 0.175. And this decimal ends up being 0.22. And that means that the left-hand side is not equal to the right-hand side. And so the events for sitting for mathematics and for tourism are not independent events. So whenever the word independent events comes up, you have to prove this equation, the product rule, that the probability of something and something is equal to the probability of the first thing times the probability of the second thing. And if the left-hand side is equal to the right-hand side, then the events are independent. And if the left-hand side is not equal to the right-hand side, when you convert to the decimal, then the events are not independent. All right. Okay. Final question here in this paper, question 12. A company generates a 4-character code using the 26 letters of the alphabet and the 10 digits from 0 to 9. The code is in the form letter, digit, letter, digit. Determine how many different codes can be formed if letters and digits may be repeated. So the letter then can be 26, right? The digit can be 10, there's 10 digits. If the letters and digits may be repeated, then this is 26 and 10. So the first 4-digit code can be 26 times 10 times 26 times 10. Right? That gives you an answer here to be 67,600. That's for the first question. 26 times 10 times 26 times 10. Right, okay. It's the first one. Next one says, the letters D, F, I, Q, U, and V may not be used. So let's just see how many letters may not be used. 1, 2, 3, 4, 5, 6. 6 letters may not be used. Code may not start with a W or a Z. All right. Letters or digits may not be repeated. Got it? And the code ends with an odd digit. Okay. So we have our code. This is a letter, this is a digit, this is a letter, this is a digit. All right. I'm going to start with the first one. All right. Now, first of all, the first one, out of the 26 letters used, we're not using 6 of them. So 26 minus 6 gives me 20 options for the first position, except the code may not start with a W or Z. So from these 20, there's 2 that I can't use, a W and a Z. So that means that in the first position for the first letter, I only have 18 options. Right? 20, I would have had 20, but again, they said, how did I get 20? First of all, I can't use these 6 letters, right? So 26 minus that 6 gives me 20 options for the first position, but the code may not start with a W or a Z, so that gives me 18. To look at letters or digits may not be repeated. So in this position of the letter, again, I would have had 20 options, but letters and digits may not be repeated. So whatever this letter was, I have to subtract 1 because letters may not be repeated. So I need to subtract 1 from this option, which gives me this position to be 19. So I put a letter down here. I can't reuse it. So this is going to be 19 options instead of the 20. Had I been able to reuse, then this option here would be 20. Letters being repeated, or it was allowed, the code allowed for the letters to be repeated, then this letter would have been 20. I could have used 20 options without these 6, right? But because letters may not be repeated, whatever letter I put down in the start here, from those 18, I can't use it again. And so this gives me, out of the 20 options that there was, that gives me 19 options there for that letter. Right, then digits. The only restriction is these 2, right, for digits. The code ends with an odd digit. So I'm going to go here first. It ends with an odd digit. Odd is 1, 3, 5, 7, 9. That means 5 options there, right? There's 5 options, 1, 3, 5, 7, and 9. So the code is going to end with that. This digit, so this was a digit. One of the digits was put down from 1, 3, 5, 7, 9. This would have been 10 options had the code allowed for digits to be repeated. But because they're not allowing for digits to be repeated, whatever digit I put down here from 1, 3, 5, 7, and 9, I can't use that digit again, which means now I only have 9 options in that position. So it's 18 times 9 times 19 times 5 for 12.2. All right. That then gives me an answer of 15,390. The last question says, the company wishes to increase the number of 4 character codes formed in question 12.2 by allowing D, F, I, Q, U, and V to now be used. Calculate the percentage increase in the number of different codes that can now be used or can now be formed. So this restriction no longer applies in 12.3. That's the only restriction that no longer applies. So now what's going to happen is in my 4-digit code, we have your letter, your digit, your letter, your digit, right? The digits, they didn't say anything about that. But for the letters, they're now including these 6 letters that they originally took out. So the first digit still may not start with a W or Z. So it would have been 26, but because it can't start with a W or Z, it's now 24. Right? And this one is 1 minus that, just like, not 1 minus that. It's 26 minus the one letter that was put down here. So this letter is the 26 options minus the one letter that was put down there, which gives me 25 there. So this is 24 times 9 times 25 times 5. I hope that made sense, right? Okay, but the question is very specific. It says calculate the percentage increase. Percentage increase is from grade 9. The percentage increase of something is new minus old over old times 100. So this is the new code, the new thing that they're allowing. This answer ended up being 27,000. So to calculate the percentage increase, it's the 27,000 from the new thing that they're allowing minus the old one, which was 15,390 over the old, which is 15,390 times 100. To get the percentage increase, it's 75.44%. That's the percentage increase just by allowing that additional 6 letters. All right. Okay, that paper was hectic, honestly.